Welcome all. Let us continue with the 11th chapter, and today we'll be studying two theorems, the theorem of parallel and perpendicular axis and also torque and its relation with moment of inertia. Of parallel axis. According to this theorem, the moment of inertia of a body about any axis is equal to its moment of inertia about a parallel axis through its center of mass ICM plus the product of mass of the body and square of the perpendicular distance between the two parallel axis. So here, if A is the distance between the two parallel axes, then by the theorem, the I, which is moment of inertia, will be ICM plus MA square. The next is the theorem of perpendicular axis. The moment of inertia of a plane lamina about an axis perpendicular to its plane is equal to the sum of moment of inertia of the lamina about any two mutually perpendicular axes in its own plane and intersecting each other at a point where the perpendicular axis passes through the theorem. Here, if you see, the total moment of inertia will be about the z-axis, which is equal to the sum of moment of inertia about two perpendicular axes, that is about ix and iy. You studied in your class 10th, the turning effect of force is the torque or the moment of force. It is defined as the product of the magnitude of force and the perpendicular distance between the line of action of force and the axis of rotation. So the distance is also known as lever arm or the moment arm. Now, in form of vector, the torque is defined as the vector product of position and force vector. So the magnitude of torque is Rf sine theta, where theta is the angle between the position vector and the force. In terms of vector, torque is equal to R cross F. The SI unit of torque is Newton meter. The dimensions are same as that of work, which is ml square t minus 2. The direction of the vector is perpendicular to the plane containing R and F. Now here, let us take some special cases. When theta is 0 or 180, in that case, the force passes along the origin, so sine theta is 0 and torque is going to be 0. When theta is 90, torque is Fr and is maximum, which explains why it is easier to open or close the door when we apply the force perpendicular to the door at its outer or free edge. Now, let us calculate the work done by the force that is acting on a rigid object. Now, the work done is the product of force and the displacement, that is ds. Now, ds is the linear displacement, which can be written in terms of angular displacement as the product of the angle d theta and the radius r. The angle is arc upon radius, so the length of the arc ds will be equal to r d theta. Now work is equal to Fr d theta. Fr is the torque, so we write dw, or the work done, is torque d theta. So the work done is the product of torque and the angular displacement. The power delivered by the torque. Now work we know is tau d theta. dividing by delta t. So delta W upon delta t is the rate of doing work, which is known as power, will be equal to tau d theta by dt, which is torque into the angular velocity. Relation between torque and moment of inertia. If we see the diagram, it shows a rigid body which is rotating about a fixed axis with an angular velocity omega and a uniform angular acceleration alpha under the effect of a torque. Now the body consists of a number of particles m1, m2, m3 and so on up to mn, and their perpendicular distances from the axis of rotations are R1, R2, R3 and so on up to Rn respectively. As the body is rigid, the angular acceleration for all the particles is going to be same. However, the linear acceleration of the particles from the axis will be different, which is a1, a2, a3 and so on up to an. The value of a1, the linear acceleration in terms of angular acceleration, is the distance from the axis of rotation, and the product of angular acceleration is the linear acceleration. So a1 is r1 alpha, a2 is r2 alpha, a3 is r3 alpha and so on. For n particles we can evaluate simultaneously. The force on each particle will be m1a1, or which is m1 r1 into alpha. F cross r, which is the moment of inertia, will be m1 r1 square into alpha. So for all the particles, the total torque acting on the body will be the sum of the product of masses, the square of their distance from the axis of rotation, and angular acceleration. So the torque is summation mi ri square and alpha. Mi ri square is the moment of inertia, therefore the torque is the product of moment of inertia and angular acceleration.